Hey guys, today we're going to talk about logarithms. This is just going to be a follow-up from what you looked at yesterday. So on your notes here, we have this question, what is a logarithm? And here's the definition. A logarithm is another way of writing exponents. If you remember from Algebra 1, you talked a lot about exponential functions. Now, on a coordinate plane, those functions looked like this, where they grew very, very quickly, or if it was exponential decay, it fell very quickly. You talk about that sometimes when you take chemistry, and you talk about half-life also. So what we're going to do, we are going to learn how to convert between logarithmic form, we call that just log form, and exponential form. So what we're going to do here, we have log base b of a is equal to x. If I want to put this in exponential form, I want to write this where it's going to have an exponent. So if I'm putting it in exponential form, I draw an E. I start here at the base, I go through x and around through a. So to write this in exponential form, this is going to be b raised to the x power equals a. Now this little b is going to be the same thing as this bigger b, okay? Both of these are considered the base of the function. Okay, right here it's equal to x. Over here the x is up top as an exponent. And then over here it's log base b of a. Here b to the x power is a. So basically the log of a number is an exponent. X here represents my exponent. So in this next section where we're converting logs to exponentials, okay, I want to talk about what each piece is again, okay? So right here, b is what I call the base. X is the exponent. And a is what we would call the solution or the answer to the problem. Okay? So I know that you did some of these yesterday, so here I'm only going to do the odds. If I want to rewrite it in exponential form, I'm going to draw my E. I'm going to start here at the base, come through 2, and down through 9. That will be 3 raised to the second power is equal to 9, and that is a true statement. Okay? Number 3. Start at the 7, go through 0, and end with the 1. So this is 7 raised to the 0 power equals 1. We know that is true because of our exponent rules. We know that anything raised to the 0 power is equal to 1. Okay? And then this one right here, this one looks a little funny because it's got a fraction. Okay? Right here, we've got 4 through the negative 2, right here through the 1/16. Okay, that would be written 4 raised to the negative 2 power is equal to 1/16. Now we know that this is going to be a true statement because we know we're not allowed to have negative exponents. In order to get rid of negative exponents, we have to create a fraction that drops this 4 down to the denominator and makes this 4 to the second power, which is 16. Okay? Now, if I want to write them the other way, if I want to take the exponential form and put it in logarithmic form, I'm going to draw an L, kind of like a little block letter L. Okay? So I'm going to start over here. I'm going to come down through the 14, over to the 196, and end at the 2. So this will be written log base 14 because 14 is the first number that I touch, of 196. I go from 14 to 196, and then I end at 2. Log base 14 of 196 equals 2. All right, I'm going to do the same thing here. I'm going to come down through the 12 over to this 12 and end at the 1. So this will be log base 12 of 12 equals 1. And then last right here, I've got 2 over to the 1/8 and end at the -3. So this is going to be log base 2 of 1/8 is equal to -3. Now, anytime I take the log of a fraction, my answer is going to be negative because I would need a negative exponent to create that fraction, okay? Now, just to go back over this, if I have log base b of a equal to x, here are my different parts. This little b right here is referred to as the base. Very similarly to this big B up here being the base, okay? The A is my solution, and the x here is my exponent. Can't spell this morning. Okay, so the log of a number is an exponent, okay? All right, take a minute, press pause on the video, and I would like for you to very quickly do the evens. Okay, all right, so just to check yourself, if I'm putting in exponential form, I'm going to draw my e's. Okay, so right here, this one should have been 6 to the 3rd power equals 216. This one should have been 2 to the 4th power equals 16. And this one, 9 to the 3/2 power equals 27. Okay, now also, just to review from the beginning of this semester, if I raise something to the 9/3 power, that's going to be the same thing as taking the square root because the denominator comes around and it's the index. It's unwritten right here. And this 3 remains as the exponent. Okay? All right, and then here are the ones that I was putting in logarithmic form. I'm going to draw my L's real quick. All right, so here I have log base 3 of 81 is equal to 4. Here I have log base 36 of 6 equals 1/2. Raising something 36 to the 1/2 power is the same thing as taking the square root of the number. So square root of 36 is 6. Okay, so that makes sense. Here I have log base 8 of 16 equals 4/3. Flip your paper to the back, please, and let's look at this top definition. A common logarithm. A logarithm with a base of 10 is called a logarithm, okay? Now, it says right here, it can be written without the base. You're going to see right here, if I have log base 10 of x, this is going to be equivalent, okay? Because just like when I have the variable x, there's an understood but unwritten exponent of 1. There's also an understood but unwritten coefficient of 1. So that is just equivalent to x. That's just without all the frou-frou stuff put with it. okay? So what we're going to do, we're going to take that information and we're going to learn how to evaluate logarithms, okay? Now these are very simple ones. They can be done without a calculator. So that's what we're going to do, okay? It says use your knowledge of exponents to evaluate the following logarithms. Okay, so I am going to start here by setting this equal to x. I know that I've got to solve this for something. Okay, this is in logarithm form. I want to put it in exponential form. So I'm going to draw my e very quickly. Okay, I have 7 to the x power equals 49. Now I'm just going to use my common sense skills. I'm not going to use a calculator. And I'm going to ask myself, what can I raise 7 to? What power can I raise 7 to give me 49? And the answer is 2. 7 squared is equal to 49. Okay? All right, next, number 14. I'm going to set log base 3 of 27 equal to x. I want to put it in exponential form to evaluate it. So right here, this is 3 to the x power is 27. I'm going to ask myself, what can I raise 3 to? How many times can I multiply 3 by itself to give me 27? And the answer here is 3. Okay? All right, for this next one, it says log 100. There is no base written, but if you remember up here, we just said that that is an understood but unwritten base of 10, okay? So I'm going to write in that 10 just for our purposes for now, and I'm also going to set it equal to x. So I'm going to put it in exponential form. 10 to the x power equals 100. Okay? What can I do to 10 to get 100? Well, I can square it. So x equals 2. All right. For number 16, I'm going to set it equal to x. I'm going to very quickly put it in exponential form. I'm going to do 12 to the x power equals 1. Now, what exponent can I raise 12 to so that it's going to give me 1? The answer is 0. It is okay to get 0 or a negative number for these solutions. Okay? All right, here we go with the last 4. I'm going to go ahead and quickly set all of them equal to x. And I'm going to go ahead for all 4 of these, and I'm going to draw my little e's. Now, hopefully, once you get used to the process, you won't have to draw the e's. But even for me, it's a good visual, and it helps me to see them, okay? So right here, I'm going to rewrite number 17 as 2 to the x power equals 64. I know that if I raise 2 to the 6th power, it's going to be 64, okay? 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times another 2 is 64, okay? All right, then next I've got 3 raised to the x power equals 243. And here I need to think through my multiples of 3, okay? So I've got 3, well, it's more than just multiples of 3, but 3 squared is 9, 3 to the 3rd power is 27, 3 to the 4th power is 81, and 3 to the 5th power is 243. So this will be x equals 5. And I'm putting a box around my answers just so it stands out and there's no confusion about what my final product is, okay? All right, right here on number 19, this is going to be 9 to the x power is 1 over 81. Well, just a minute ago, we said that in order to create a fraction, there had to have been a negative exponent, okay? So I know that my x value is going to be negative. 9 to the what power gives me 81, and that would be the second power. So if I do 9 to the second power, that's going to give me 81, okay? All right, and then next I have 64 raised to the x power equals 4. Okay, so right here I want you to notice that my number got smaller this time. It appeared on all the other ones that my number got bigger. So if my number is getting smaller, there's probably going to be a fraction as my exponent, okay? And right here, what I know is that if I take the cube root of 64, then that's going to give me 4. If I multiply 4 by itself 3 times, that is going to give me 64. So the opposite of raising it to the third power is going to be raising it to the 1/3 power. Okay? So there we go on that part. While we have milestone testing going on, we are down some of our graphing calculators, but we should have these little yellow calculators that will be helpful to us here, okay? All right, so as we solve logarithms, we need to know not all of them are going to be able to be solved without a calculator, okay? But the calculator also has its own quirks. When I find the log button on my calculator, now on this calculator, it's right here underneath the second button. When I hit log, it opens up log and has this little flashing thing for me to type in this part of my solution, this big number, okay? The calculator only understands logarithms to be in base 10. So I am going to have to find out a way so that I can calculate these ones that have different bases. Okay, not all calculators have the capability of changing the base to whatever it is. So we have this thing called the change of base formula. What I'm going to do here, in order to convert this, okay, I'm going to take the log of A and I'm going to divide it by the log of B. Now, A is my larger size number, doesn't necessarily mean it's bigger, okay? It is going to go up top. And then log base B, since this is in the base, this is going to go down. This one is going to go on the top. So this is going to be my numerator. That's going to be my denominator, okay? Let me show you what I mean by that. Okay? Now, so what I'm going to do here, I'm going to do log of 64 over log 16. Okay? So I took the log of the big number divided by the log of the base. And what I'm going to do, I'm going to do this in my calculator. I have log of 64. It's very important that I close my parentheses. Okay? Make sure you close your parentheses and then divide that by log 16. Hit enter, and it gave me 1.5. Okay, they're not always going to come out to be pretty decimals like that. Okay? All right, number 22. I have log base 8 of 32. So I'm going to go ahead and get this set up. I'm going to do some division. I'm going to do log of 32 divided by log of 8. Okay? So when I put this in the calculator, I'm going to do log of 32 and close my parentheses divided by log of 8. Close my parentheses and hit enter. And I see that I've got 1.6 repeating. So I'm going to write 1.6 and I'm going to put the bar over it just to indicate that it continues on forever. Okay? All right, next. I have log of 54 divided by log of 2. to go ahead and set up the remaining problems, I have log 294 divided by log 10. For 25, I would do log 136 divided by log 4. Remember, I'm putting my base in the denominator. And then here, excuse me, I've got log of 136 over log 6. All right, so I'm going to use my calculator to help me solve these. All right, for number 23, I had log 54 divided by log 2. And I want you to notice that gave me a much longer decimal this time, which is fine. Okay, I'm going to round this to 5.7549. I am going to carry it out a couple more decimals. All right, for number 24, I have log 294 divided by log 10. When I hit enter, that gives me approximately 2.4683. Okay. Now, I also want to show you, since this was log base 10 of 294, if I just hit log and do 294 and hit enter, I got the exact same thing. So if I have log base 10, then I can just type that in the calculator, okay? All right, next I have log of 136 divided by log 4. Okay, got another decimal. I'm going to round that to 3. Let's see, not 3. That would be 2. Oh, I made a mistake. Look what I did. Okay, does everybody see right here? I've got log of 136. What did I not do? I did not close off my parentheses. I knew that didn't look right. So right here, I'm going to redo this. I'm going to do log of 136, and I'm going to close my parentheses, and I'm going to divide it by log 4. That's it, okay? So I get 3.5437 as my approximation. Okay, I'll be careful not to make that mistake again. And then here, for the last one, I'm going to do log of 136, just 1 divided by 36. I'm going to close off my parentheses, and I'm going to divide it by log 6. And that gives me -2. That gave me a pretty number, okay? So today you're going to practice with each one of these things that we have done on this paper. Okay, just make sure that you complete it thoroughly, make sure you complete it accurately, and as always, please know that you have all of us around you to help you, but you have to come ask for help, okay? Thanks. Have a great day.